everyone. So this is the second question based on bending stress. So here in the question it says that determine the bending maximum bending stress developed in a beam of rectangular cross section of size 50 into 150 mm when a bending moment of 600 Newton meter is applied about x axis. So here what we need to do is given that so here what we need to find is sigma b. Sigma b is nothing but the bending stress. Here the beam is of rectangular cross section, so this is the rectangular cross section of 50 mm and that is 150 mm, and here the bending moment m is also given, that is nothing but 600 Newton meter. So now we know the formula of bending for finding the bending stress, that is m by I is equal to sigma b by y. So this is the formula for finding the bending stress. Now this moment is already given in the question, and I value for a rectangular section, we know that I is nothing but the moment of inertia. Okay, so moment of inertia for the rectangular section is b d cube by 12. So now b is also known to us, d is also known to us, just we need to put the values here. B is nothing but 50 into d is 150 cube divided by 12. So we'll get the answer around 14.06 into 10 to the power 3 millimeter to the power 4. So now here we need to find this, then we need to find the value for y now. So y is nothing but the distance of the neutral axis to the upper layer. So suppose see, this is a cross-sectional area of the rectangular beam, and from the middle it's the neutral axis. So from this distance to this distance is the y value. So we know the overall depth is 150 mm. So this distance will be d by 2. So d by 2 is equal to, d is what, 150 divided by 2. Then we'll get the value for y about x axis is 75 mm. Now we just need to put all the values, put all the values in the bending equation. So this is our bending equation, that is m by I is equal to sigma b upon y. So we'll shift this y that side, then the equation will become sigma b is equal to m by I into y. So we have a value for every this one. So m value is nothing but 600 Newton meter. So 600, and I value is 14.06 into 10 to the power 6 into y is 75. So we'll get the value around 3.2 Newton per millimeter square. So in the question what it says that we need to find the maximum bending stress. So this is the value for the maximum bending stress. Now we'll draw a bending stress distribution diagram. So here, as this is a rectangular section, so this is the neutral axis. So here for this type of a rectangular section which is equally distributed, so here the distribution diagram will be equally distributed. So for here this is sigma c, compression side, and this is for the sigma tension side. This is stress as tension and this is stress as compression. So this is the bending stress distribution distribution diagram for a rectangular beam section. Okay, thank you.